Hello, everyone. Thank you for coming tonight to San Jose State Student Chapter of ASIS presentation from Dr. Michelle Chen. She is a lecturer here at the School of Library and Information Science, and she is currently teaching Information Visualization, which is a section of Library 246. This is a really relevant topic. It's something that libraries and library science students are going to be dealing with more and more, and we just are really thankful that she was willing to come and tell us a little bit about her work and her perspective on this issue. So thank you, Dr. Chen, and take it away.
Thank you, Amelia, for the great introduction. Hello, everyone. My name is Michelle Chen, and thanks for joining us for the next 45 minutes to 1 hour. I'm very happy to be here today to talk about information visualization and its role in library and information science. As I discussed with Amelia, I'm not going to dive too deep into the technical details, such as the visualization techniques, because I'm not going to overwhelm you in just a very short period of time. So instead, I would like to talk about the role of information visualization in a library and information science setting, and why it is important for us librarians, archivists, information professionals to know information visualization field. Sorry, let me read the question. I forgot to actually say the question. Oh, okay. So if you don't mind, we can save our questions for the end, and I can answer all of them at once. Thank you. Okay, so I would like to first start my presentation with a very fundamental question. Why do we want to study information visualization? Okay, so what is the motivation there? Well, here are some reasons that I think are convincing and interesting. So first of all, the White House's big data initiatives and policies have made one of the biggest changes around data and libraries in the past 2 years. And this change of policy landscape has put a greater emphasis on so-called the public access to the results of research funded by the federal government. Okay, so for example, NIH policy requires research written as a result of NIH funding to be deposited full text in PubMed Central within 12 months of publication. So that simply means if your research is funded by the government, then you're required to make it public within the 12 months of publication. So this has created a momentum in academic libraries and some of the public libraries to share data. So for example, Harvard has recently made public the information on more than 12 million books, videos, audio recordings, images, manuscripts, maps, and more things inside its 73 libraries. And quoted from David Weinberger, who is the co-director of Harvard's Library Lab, this is big data for books and publications. And there might be 100 different attributes for a single object. So with such abundant information, people can create things like visual timelines of when ideas became broadly published or maps showing locations of different items. And the Harvard's action will encourage other libraries, and actually they just launched last year, I think, there's a Digital Public Library of America, which kind of coordinates different public libraries around the states, and to join the data sharing initiatives, and it has encouraged other libraries to allow access to the metadata on their volumes. And I think this could be the start of a large and unique repository of intellectual information. So, as a result, data can get bigger and bigger. And information visualization is considered one of the emerging technologies and probably more user-friendly technologies to help us analyze and understand big data sets. And last but not least, our motivation comes from the increasing job opportunities. So there is a strong need for information visualization professionals. And as you may have known already, some career options include visualization developers, business intelligence analysts, who combine not only the the data analytics, but also the visualization techniques. UI developers in design studios, research labs, analytics groups, etc. So that all made it a very promising field to study. So let's go back to information visualization. So how and why can human vision help? Okay, so we have a bunch of data. We already have other technologies like data mining, if you are familiar with that, and also some other statistical models. So why do we still need information visualization, and how can human vision help? Well, human perceptions come in many different ways, as we know, through smell, taste, ears, and vision. And among all those senses, vision has the highest bandwidth, which means it is around 100 megabytes per second compared to, let's say, ears, which bandwidth is less than 100 bits per second. So that simply means the processing power of vision is pretty fast and very powerful. So human vision is powerful. In addition, human vision is called pre-attentive. I noticed that some of the attendants today are actually come from my visualization class, so you might find it a little bit repetitive, but that's okay because we're doing it for the general audience. So human vision is pre-attentive, which pre-attentiveness is broadly defined as the visual process that operates before humans attend to an object. So let's say during the stage of visual search, early visual processes operate in parallel over a large portion of the visual field extracted from each item basic visual features. So let me give you an example. Human vision is very selective when it comes to different sizes, shapes, colors, spatial positions, etc. So let's say if you notice, if you look at a visualization and you find out there is a really large circle compared to some very small dots, then your pre-attentive model would lead you focus on the very large circle immediately. So that's called, before you actually get into any cognitive process. So we say that human vision is very pre-attentive, and that makes all the processing really quick. And so that is why human vision is very powerful in understanding the data. And also by organizing and presenting our data in a very selective way, we can actually influence human vision into different interpretations from the data using different visual displays. So you can select your colors to emphasize your ideas, or different shapes to present your ideas. So by relying on the human vision, it can also help extend the memory and cognitive capacity. And again, I'm not going to go into too deep in this psychology field, but you can imagine when you are looking at something that has been designed in a very visual, compelling way, then it's easy for you to remember it for a longer period of time, and also to increase your cognitive capacity. All this results from the fact that people actually think visually. Okay, so like the old saying says, a picture is worth 1,000 words, and seeing is believing. So that's why we want to use human vision to help us understand data better. And we want to go beyond just data mining, data analytics, and statistical models, and to incorporate vision models to help us understand the data. So here's an example, okay? So if you are given the data like this, and you have the information of the states, the college degree percentage, and the per capita income. And if you're asked these 3 questions, which state has the highest income? Is there a relationship between income and education? Are there any outliers? Okay. So I'll give you just 2 seconds, and you can think about, can you answer these questions immediately? I'm afraid by just taking a look at the data, we might not be able to answer these questions immediately. However, if we just use a very simple scatter plot to graph this data like this, then you're able to answer these questions much faster, or even discover new knowledge. For example, right here we see, yes, there indeed exists a proportional relationship between college degree percentage and income. And among all these states, Nevada, Utah, and North Dakota seem to be an outlier, or at least more on the border. You can even answer some more complicated questions such as, given a certain amount of income, which state has the highest percentage of college degrees? And that's very easy. You can just have a certain point, fix a certain point at x-axis, and look for the highest number at y-axis. Okay, so this is something that we use every day with Excel charts, and it's just a very simple example to show you the power of visualization. And you can see here the data is very limited. We only have a few columns and rows of data. So what if you are given 1,000,000 rows of data? Or even like in big data sets, sometimes we can have more than like 1 petabyte, which is 10 to the 15th degree data in a single data set. So trying to display the data in a visual way will be very helpful for us to understand the data layout. So now let's take a formal look at what information visualization is. Here I provided 2 definitions, which are very commonly seen and very powerful. The first one, visualization is the creation of 2-dimensional or 3-dimensional representations of data that enables new discoveries of insights and knowledge. Okay? A visualization is also the use of computer-supported interactive visual representations of data to emphasize cognition. Both of them are widely adopted definitions of visualization, and as you can see here, they actually both emphasize on 2 things. Okay, so first of all, visualization is used to discover new insights and knowledge through graphical means. So the key point here is we use visualization to discover new insights. So it's not only about the picture. Second, it is actually a presentation of data that amplifies cognition. So that's the reason why we just mentioned earlier in the previous slide that the pre-attentive processing model of human vision is very important. Because when we design the visualization, we actually trying to influence the cognitive process. So it's not just simply put different colors all together. There are some cognitive theories behind that people think it might be more powerful and compelling to design like that. Okay, so to further define the characteristics of visualization, let's look at 5 different characteristics of visualization, and that will help you understand the idea better. So the very first characteristic of visualization is computer supported. So visualization is usually displayed by computer and using some advanced software. Well, Excel charts are definitely part of visualization, but there are a lot more can be done by different software on the screen. And second, visualization is about interactivity. So visualization should be manipulated simply and directly in a free-flowing manner, including actions such as filtering the data, drilling down to focus on details, etc. Or sometimes you can see you might have a sliding bar to show different years. And when you select a certain year, then you will see the visualization within that year. So that is all interaction. Third, it's about visual representations, of course. So the information is displayed in visual form using attributes such as location, different lengths, different shapes, different colors, and sizes of objects to form a picture of the data, and thereby allowed us to see patterns or trends, or even to spot exceptions and outliers. And next, information visualization deals with abstract data. Okay, so abstract data refers to information such as quantitative data, processes, or relationships that is considered abstract, in contrast to visual representations of physical objects such as geography or the human body. Okay, so we're dealing more with the abstract data, for example, baseball statistics, stock trends, internet transactions. So this does not have These do not have physical objects like the geography or human body. So we call this abstract data. And that is where visualization comes into play. The last one is, again, we want to use visualization to amplify cognition. And interacting with these visualizations extends our ability to think about information by extending the memory and cognitive capacity. All of these are important, and as I just mentioned earlier, we especially want to articulate and emphasize on amplifying cognition by using different features when we do the design of visualization. Okay, so the purpose of visualization. Visualization is often thought of as a process of making a graphic or an image. But really, visualization is a cognitive process. So the purpose of visualization is insight, not pictures. This is something a lot of people will usually get confused because they want to design a really good picture. But what we want to have from visualization is what we can get from the pictures. So it's not just about the design of the pictures. So we say there are two main uses in information visualization. First is analysis. You understand your data better and act upon that understanding. And the second use is presentation, which is very important. You want to communicate and inform others more effectively through visualization. So this figure explains some of the activities and goals in information visualization. So first of all, data visualization is a big umbrella that covers two topics, information visualization and scientific visualization. Scientific visualization is usually concerned about the three-dimensional physical structure of an object, such as we said earlier, the human bodies and geography, while information visualization focuses more on analyzing abstract data. Both of them have the activities including exploration of the data and sense-making. And ultimately, we want to communicate and inform others more effectively. For technologies, information visualization uses graphical presentation to show the data and understand our data more thoroughly. And finally, which is something we would like to keep in mind, the end goal is to make good decisions based on our data. Okay. So now let's take a look at two very interesting examples of visualization. Again, as I just mentioned earlier, in Excel, the basic charts that we saw, let's say pie charts or line charts, these are definitely part of visualization. But here I would like to show you two more advanced examples of how visualization can be used to achieve better communication and presentation. So the first example shows the storytelling concept presented by IBM Research in the latest Digital Library Conference. If you just Google, for some reason my computer, the application sharing on my computer doesn't really work, so I can't really show you the interactive features here. But you can simply Google CNN Home and Away project, and that will lead you to the actual project site where you can actually play around with different visualization features. So this project is called the Home and Away project from CNN, which presents military casualties in Iraq and Afghanistan. The visualization tool connects the location of each trooper's birth and death along with some demographic information. And this visualization platform is integrated with CNN's iReport platform, allowing families and friends of the deceased to tell their personal stories. So I really like this example because I feel this is very inspiring. Thank you, Analia, for the link. Here, visualization is not only a tool for discovery and analysis, it is also a powerful medium for communication. This shows that information graphics can do more than just presenting numbers. They tell their story, engage and convince the readers, invite the readers to make a personal connection to the data, and help them tell stories of their own. So this is I want to show you this kind of an ultimate goal of using information visualization for a better storytelling experience, and also especially to connect users with the data directly. The second example is a very interesting one. It shows the baseball star Barry Bonds' home run records with his allegations of steroid use. So in this graphic, the image of Bonds is sized prominently and placed in the upper left corner of the page, hoping to grabbing the eye and pointing the viewer towards the title. So you saw the Barry Bonds there, okay? And this establishes the topic for the rest of the graphic. And right next to the title, a legend consisting of photos and text introduced Hank Aaron and Babe Ruth, two previous home run leaders whose careers provide points of comparison for Bonds' career. And on this graph, you can also see a line chart of accumulated home runs, show that the three hitters' careers in alignment, with Bonds' home run accelerating at a time when the other hitters slowed down. Okay. A shaded annotation also notes that the acceleration coincides with the first reports of steroid use in Bonds' 14th season, accompanied by a second annotation just 2 years later when Bond takes the lead over Ruth and Aaron. Okay, so now if we move our eye to the right side of this graphic, where a large image of a swinging Alex and Erod is shown. Okay. Here we can see the other current players who are chasing the career home run records, and the button section is given minimum visual priority but completes the story. Here we use a so-called technique called the small multiples, which means you put some small visualization. They all show data with the same scales and the same X and Y axis, but with different clusters or different groups. So it's called the small multiples. And we use these small multiples to increase the data density, because we will try to, look at the amount of work to create. Yeah, we'll try to put as much data as possible in the graphic without misleading the users. And small multiples are sometimes a very good popular one to use. And these small multiples show the home runs per season for top players on the career home run list, each captioned by a factoid. So you can see several visual elements are being applied here. We have the whole space is divided into smaller sections, each telling its own sub-story with charts, pictures, and text. The three sections, the large steroid usage lines and the era to the current players and the small multiples. The three sections are linked together graphically through the use of different colors, shapes, and text. And the graph allows us to immediately discern the reference to the larger image. And one thing to notice is that while these elements provide seamless transitions between sections, they do not have the order in which the viewer explores the visualization. And rather, a path is accomplished through the use of visual highlighting, such as color, size, or bonus, and connecting elements such as arrows and shared trails. Okay, I think there's several ways to establish. I think this is another example showing that visualization can be used for storytelling, which is one of the ultimate goals, and how it differs from traditional storytelling. Okay, it really depends on how you design the graph and how human vision perceives the visual cues to tell the story. Okay, I know I touched upon some of like small multiples and different colors, shapes for pre-attentive modeling, but again, I'm not going to too deep into the technical details because that would make our presentation super long for the whole semester. I would like to talk about something more interesting and a little bit different. I would like to discuss with you the role of information visualization in a library setting. And let's think about why it is important for librarians, information scientists, archivists, or record managers to be active in information visualization. So first, I'd like to show you some real-life examples of libraries that have made information visualization infrastructure as one of their research, service, or communication tools. And I need to especially thank my visualization class students last semesters and also current semester for contributing a lot of information on the slides and the talk. So the first example is about information visualization service provided in the library. This example is the Health Sciences Library at the University of North Carolina at Chapel Hill, partnered with the Renaissance Computing Institute to build and provide visualization infrastructure and expertise as one of the key services of its collaboration center. And I personally found this is very powerful and very interesting tool that a library can provide. With this service, researchers can consult and collaborate with visualization experts to develop custom applications to analyze data. So the center's visualization resources include a display wall, as you can see on the left figure, with a 10 feet by 8 feet rear projection display screen capable of 12.5 million pixel resolution, which is quite large. And the right figure here just shows you an example that a visual display has been conducted to aid the research on injury prevention. So the figure on the right shows a dynamic bubble visualization of all injury rates with GDP per capita for countries in different WHO regions and presents how these variables change over years. And visualization can select single or groups of countries and trace their trajectories over time. And I really like this neat idea provided by the Health Science Library. The ability of researchers to interact with the very high-resolution imagery images from the screen on the display will provide opportunities for new collaborative applications. And also, the end users do not really have to have much knowledge into using information visualization applications. They can consult and collaborate with the librarians, and they can build their applications. So that is the first very neat example. The second real-life application comes from Seattle Central Library. And this is the Making Visible the Invisible project, which is a commission for the Seattle Central Library. It is a large, open, 19,500 square foot space dedicated to information retrieval and public accessible computer research. And the installation consists of 6 large LCD screens located on the glass wall behind the librarian's main information desk, as you can see from the photo on the left-hand side. The screens feature real-time calculated visualizations generated by custom-designed statistical software using data received each hour. So the data consists of a list of checkout items such as books, DVDs, CDs, etc. And from the list, they can collect and aggregate titles, checkout time, and catalog descriptions. Believe it or not, there are approximately 22,000 item circulation per day. So you can see some visualization snapshots on the right. It's not very clear, so I'll just explain that verbally. So for example, the second visualization features the checkout items in a chronological sequence. So each time spent titles enters the screens from the far right and slowly moves towards the left until the whole hour set of items have passed by. The circulation of checkout books and media transforms the library into a data exchange center. And I really like that idea, and I think from a cultural perspective, the results may be a good indicator of what the community of patrons considers interesting information at any specific time. The third example is not about the physical visualization infrastructure deployed in the library, but it's about how information visualization can be used to deliver library messages. This is one of the most widely discussed infographics in the library field, and I also share this with my information visualization classes. So this is the banned books infographics, and every banned weeks we have this kind of infographics. And this one has been chosen the best information design and data visualization from the internet by the Daily Infographic blog, and is one of the most widely discussed one. And this infographic displays the most challenged or targeted books of 2009. And according to the infographic, even in 2009, certain parents didn't like how To Kill a Mockingbird handled racism. And Twilight couldn't dodge the censorship bullet, as parents felt it was both unsuited to its target age group and sexually explicit. And so this is another way to view visualizations. Here we are trying to tell a story, but not a traditional kind of story, but we can use different, more visually compelling elements to attract users and to help them understand our ideas better. So I hope these real-life examples and applications have given you some ideas of the practical role of visualization in a library and information science setting. So back to our question. Why is it important for us to be active in information visualization? Well, based on our real-life examples, I have concluded 3 main reasons. I believe you can come up a lot more, but these 3 reasons are something from my personal experience and also from the brainstorming of my visualization courses. First of all, no doubt a library is a data center. It is a hub where information flows and exchanged. We can find a great variety of data in a library, ranging from circulation statistics to digital archives. If you have time, you can actually check out the library, California State Library. It annually publishes California Library Statistics, which is a compilation of statistical data from public and county law libraries throughout the state. However, if we take a, here I provide a snapshot of the data. It looks simply just plain Excel file. So if we take a closer look at the data that we have right now, many of them are in this plain Excel format, and that seems to point to nowhere actually. It is really a pity that we have a lot of data, but we don't know how to make an effective use of it. So with information visualization, we will be able to render data in ways that communicate information, answer questions, support analysis, reveal patterns, and facilitate new questions or discoveries. And ultimately, this will provide our patrons with better services and organizational operations. For example, for library patrons, the library could use visualizations to present things like current collection budgets, e-book availability information, statistics on library use, and data about public attendance of library programming. And these types of visualization will not only be interesting to patrons, but also provide a deeper understanding of the library's operations and the impact it has on the community. Likewise, such as in the case of the University of North Carolina and Chapel Hill's Collaboration Center, information visualization services will also become necessary services for many types of libraries. And I really look forward to having such services in our library so that we can actually just consult and ask the librarians and get some of the collaborative applications. Second, visualization can be part of library exhibition of information. Some really good infographics like what we just saw in the previous slide for most targeted or challenged books are especially useful to promote information literacy or library events. Visualization can also be used to enhance patron interactions and user experience. This is the example that is provided by my student, and I found this really interesting. I think Justin, a lot of students actually express interest in studying this. This example is the library at the University of Edinburgh, and it has search engine that incorporates information visualizations called Aqua Browser. And that presents catalog search results in the regular format, but also includes a graphical sidebar, as you can see from the snapshot here. On the right-hand side is the regular search results, and then on the left-hand side is a web of related search items displayed in the graphical sidebar. And the larger the texts are, the closer to the center term the texts are, the greater the relevance to the original search term. So this just gives you another idea of how to display the search results. Whether or not this is really effective, I think this provides us another perspective to see how visualization can be incorporated in library services and also to enhance user experiences. Another useful area of visualization in library and information work lies in governance. So the library staff could use information visualization to display physical information for the library board, county board, or committees. The library manager could use visualization to show how successful a new program is and how budget cuts are affecting certain departments, how staffing levels change over a certain period of time, etc., and also especially for fund seeking. The chat clouds. Yes, there are a lot on the web all the time, but I think for the library pages, it's relatively fewer that incorporates the chat clouds. Also, this is not only a static cloud, it's also quite interactive. Yeah. So, but this is debatable. Like a lot of people, there has been research going on saying that this kind of chat clouds are actually distracting, and it's not making a lot of work and use for user like the retrieval results. But on the other hand, a lot of people found this actually will direct users to explore other ideas and fields that they originally did not think about. For example, if you start with your search term and suddenly you are directed to other search terms that are related, but you never thought about that before, and that will create a better experience as well. So I would keep this open whether this is good or not, because this is indeed debatable. But what I'm trying to say is that this can be something that just provides another perspective for you to think about the role of visualization. Finally, this is the best part that I like. Information visualization can be used to fulfill libraries' social responsibility role. Libraries have a potential role in addressing poverty and illiteracy. And it is suggested that demographics, statistics, and measures compiled by public libraries in designing existing, often socially responsive services and programs should be coupled with community profiles, quality of life indicators, and scorecards. So visualization can be used in the analysis and presentation of such demanding data, which ultimately can echo our school's mission of improving the well-being of our communities through effective use of information. So I think it's about 40 minutes. I hope this presentation has given you a better understanding of what information visualization is and its role in library and information science. Like many online marketers have been working hard to analyze millions of actions, clicks, conversations, likes, follows, shares that happen every moment of every day on the internet to inform their strategies. I think it is time for us in libraries and nonprofit organizations across multiple disciplines to start identifying new ways to sift through and analyze the substantial amount of information gathered in real time and from large data sources. Information visualization can introduce a way to present data in an intuitive, aesthetically appealing, and self-explanatory fashion, and which ultimately enables new discovery and insights in knowledge and that can really help us, and I think that will improve our roles as librarians and information professionals. Okay, so thank you very much for your attention, and I would like to take questions. Any questions? Yes, Evan.
You mentioned earlier that this information visualization has a way of extending memory. I was just wondering if you could elaborate on what you meant by that.
Yes. So, so your question is how that can expand the memory, or?
Yeah, that's right.
Well, it's just simply use some of the different, like, we call this the visual properties. So let's say different sizes, different shapes. And I'm not a psychologist, but to my knowledge, our memory can be divided in different, like, short-term memories and long-term memories. The information visualization can especially influence our short-term memories by using really like discerning shapes or different sizes, or like really special colors that can help you memorize things better. So that simply means why they can expand our memory. Does that answer your question?
So it's basically you can help understand the data by seeing it in a visual form rather than a graph form. I think that's.
Yes, and it's actually very related to the pre-attentive model that I just mentioned. So when you use the pre-attentive processes, that means you want to design the visual displays in a way that human vision can process immediately. And that will increase the memory, that will increase the time that the items are remembered in your brain. Okay, so instead of using like statistical models or just plain text of data that we just saw in our presentation, the visual displays, by using all these pre-attentive processes and properties, let's say different colors, different sizes, we're trying to just expand the memory, and hopefully that it will last longer in your brain. So that simply means why it can expand our memory. Okay, does that answer your question, Evan?
Does. Yeah, that answers my question.
Yeah, I can give you more references on that if you are interested in. There are a lot of research, well, a lot of literature on the memory side, how visualization can impact memory. But mostly it is more related to the short-term memory. Okay, so I saw several questions here. Are you offering a course on this during? No, I'm only offering this in fall and spring semester. I would love to offer that in the summer, but I'm committed to a lot of research activities in the summer, so only in the fall and spring. You mentioned big data. Can you give a brief definition of this? Of course. Big data, first of all, it refers to a really special size of data. So usually it goes up to several petabytes. And I talked about that. So petabytes would be 10 to the 5th degree of bytes. Okay. So first of all, the definition comes from the size of the data. So it's not the simple usual data sets that we're dealing with. Even a million of rows of data do not qualify for a big data set. So usually big data refers to really large, huge data set. And very often nowadays it refers to data sets in petabytes. And another definition is that the big data is the data set that cannot be handled by the traditional database management tools or statistical models, and it requires specific software and technologies to render the data and to communicate with others. And yet another definition or just another perspective of viewing the data, the big data, especially what people are researching recently, especially come from real time. So let's say if you're looking at internet transactions or internet or tweets, Facebook likes, any follows, shares, internet transactions, all these are real time. So you can imagine if the data come in a real-time fashion, it will accumulate in a really fast-paced way. So that's the reason why people refer it to the big data. So it is there is not a formal boundary of what defines the big data, but I would say that is more like a okay. So that is the usual definition that we can see from the big data. So I would say the size of the data, and it cannot be processed using traditional data management applications, and it usually comes in real time. So like if from the library's perspective, the circulation data every day will accumulate really quickly. So if you look at per day and then if you're looking at per month, then that will probably be a lot of data that might fall into the category of big data. You're very welcome. Any other questions?
That seems like it'd be a good example of how you can use information visualization for meetings and whatnot to show your circulation data.
Right, and a lot of from my students' experiences, I think a lot of them started to use visualization right after the course to present to, let's say, committees and boards who are who probably would not be interested in looking just all the circulation statistics or the funding expenses. But if we can provide them with a more visually compelling graph, then that will make our idea a lot more convincing. Any other questions? No questions. So Amelia, would you like to take it over?
Sure. I'm curious, do you do any work with alt matrix when it comes to information visualization?
No, not really. Would you like to explain it a little bit more?
Well, I'm kind of new to finding out about this, but my understanding is that alt matrix are literally alternative matrix for measuring impact in academia. So like measuring the amount of activity you have on social media, on blogs, stuff like that. I've seen a couple different tables really going like with peer-reviewed and citations, and then the next wave is the alt matrix, the overall impact that your work is having.
Right. No, I don't really do much. I'm doing more like word clouds for spot training, and also for more like developing the algorithms. So I'm more like in the technique side. So how to better design a user interface to do visualization. But I would like to learn more about that, so we can actually talk about this more offline. Are there any prereqs? Honestly, let me check real quick. 202. 242? I can send you the current syllabus that I'm using, information visualization. So you can take a look if you are interested in that. I definitely will welcome all of you to take this course. This is not very technical oriented, I would say, but you will learn a lot of different perspectives and from design issues, from interactions, from storytelling process, and also, of course, some of the core technologies and techniques that we use for visualization. And there's also one lecture on exploring the current software for how to use, how to design visualizations. So yeah, you're encouraged to check out the website for the syllabus, and I am really looking forward to having you in my class.
Well, if there aren't any more questions, I'd just like to, on behalf of San Jose State Student Chapter of ASIS, thank Dr. Chen for joining us tonight and giving her time so graciously. That was really wonderful and interesting, and we really appreciate it.
Thank you very much. Thank you. It is my pleasure and a great opportunity for me to kind of reorganize what I have and to present this. I really enjoy it, and I thank you very much for your time as well.
Great, thank you. I'm just going to give a quick plug before everyone leaves. ASIS is having a business meeting on April 9th, and we'll be talking about internships. So join us if you can, and have a good night.
Have a good night all. Bye-bye.